we're gonna talk about the Kubernetes architecture. Okay, we'll talk about the Kubernetes architecture. The Kubernetes architecture, right? It works on a simple master and worker node component. Okay, it works on a master and worker node kind of a component, you can say. The Kubernetes architecture says that you have one control plane and you have one node. Okay, the worker nodes. You have a control plane, you have the worker nodes and other things. Now, when we talk about this control plane, right? This is the area where you have a different important components, right? Which are responsible for managing, which are responsible for scheduling, which are responsible for controlling the task. So, for example, you have HCD, you have Kube API server, scheduler, and controller manager. We'll talk about each of these. On the other side, on the worker node side, on this area, we have a different node related components which are responsible for different tasks. We have a pod, we have a kubelet, we have a Kube-proxy, and we all pods and these things are running under the CRI, which is known as a container runtime interface. So first of all, the important is this is all a distributed system. You can have multiple control plane also, you can have multiple nodes also. Most of the systems have one control plane and then you have multiple worker nodes, right? Now the point here to understand is, the important part to understand that based on these components, we need to understand each of the different components, right? And how they are responsible. Now we know that Kubernetes, right, consists of control plane nodes and worker nodes. Now, control plane node, let's talk about that. Control plane node. This is responsible for container orchestration. Means this is important part where this is responsible for container orchestration and maintaining the desired state of the cluster. This is the thing which is important here, because this is responsible to maintain the desired state of cluster. When I say maintaining the desired state of cluster, that means if the state of cluster is required to be running, it will ensure that it is keep on running. If it is required to be terminated, it is ensuring that it will go into the terminated state. Whatever the state is needed, it will take care of all of those things. How does it do? By having or by these components which are part of this control plane nodes, they allow this, they take care of managing all of these things. What are the components? Kube API server, HCD, Kube scheduler, Kube controller manager, and this is also known as a cloud controller manager. You can have right there. Now, the important part to have here is, a lot of time in interview it is asked that can you have only one control plane node or you can have more than one. So yes, you can have a cluster, a Kubernetes cluster. Cluster is what? It is nothing, it is a set of nodes which make completely all of these components are installed in that. Means if there is a cluster with the three nodes means three EC2 instances. One EC2 instances, you have a master node, you have a control plane running in, and other two nodes, you have the worker nodes running in. Okay, so that will be consist of a cluster. Okay, so together, comprising of all these three nodes together, right, they form a cluster. Okay, they form a cluster. Now, cluster can have one or more control plane nodes. For HA availability, high availability, and other environments, you can have one or more control plane nodes. Now we will talk about worker nodes. Okay, these are responsible. Above one was responsible for management part. This is responsible for running your containerized applications. To run your container applications, to ensure that you run the containerized applications and things, it does this. It has the following components, which are again very important. This part is very important, whatever we are going to do, because lot of questions comes into the interviews from the architecture itself. The worker node consists of Kubelet, Kube-proxy, and container runtime. Okay, and these things. Now, let's talk about each of these components individually. What is Kube API server? This is first of all a central hub of K8 cluster. As it exposes the Kubernetes API. As it exposes what? It exposes the Kubernetes API. Means this is what? This is a Kubernetes API. This is a place where everyone talk to this, right? Everyone will be talking to this. right, to communicate to this to ensure that you get the right commands, right answers, right? So this is the main important part, central hub, right, which can do, or which basically has contains or exposes the Kubernetes API. So all the communication will happen from here. It can be easily scalable, or it is highly scalable and handle large number of requests. Okay, large number of concurrent requests. How is it going to work? How is it going to happen? We'll see all these things. Any end user, let's say whenever we run this command kubectl get pod, okay, these are the command to run the Kubernetes example. So any end user, when they run these kind of commands, right, or any other cluster components, when they want to hit anything, they all talk to the cluster via this API server only. So everyone talk to the cluster via the API server, okay, via the API servers. So whenever you use this kubectl, right, which is basically a command, which is a utility to manage the clusters in a backend, this kubectl is doing nothing but talking with API server through the REST APIs over TLS mechanisms. This is what it is doing, and after, as it is talking between the API server and things, it is going to give you the different components. Okay, it is going to give you the different components. So Kube API server is very, very important, and with this only all the certificates and other things are also being attached. Okay, so this is also responsible. This the Kube API server is responsible for, firstly, API management. So definitely whatever the Kubernetes API endpoints and things are there, all those requests will be there. Authentication, as it has all the access and things, so it will use client certs, right? Bearers, tokens, right? Any other authorizations, anything comes into the picture, right? Authorizations using RBAC and things, all of these things will be managed by this. Okay, it will coordinate between the control node and worker node. Okay, coordinate between control node and worker node. All of these things will be there. Okay, so this is the one, which is going to do all the things. Okay, it is the component, which initiates a connection, to HCD also. Okay, to HCD also. So Kube API server is very, very important service, and that is why it is going to be responsible for managing all the Kube API related things. Any question here? Now, the next important part is HCD. HCD is nothing. We call it as a efficient distributed database. Okay, Kubernetes, it's a distributed system also, right? It has a lot of things going on. Now, as you must have heard, lot of applications have their own in-memory database. So consider this also like that. Okay, HCD is nothing. It's a key value pair based database in Kubernetes. Where what does we mean that it stores a lot of information into the HCD. It's a it is helping us to store a lot of information in this. We sometimes call this as a brain of K8s cluster. We call it as a brain of K8s cluster. Because, example, if you have made any update on a node, okay, there is a EC2 instance or something, you have made any update on a node or anything, now that communication or that node update has to go where? It has to go to all of the things, right? So it helps us to do on that. Means, I would first of all say that HCD is strongly consistent. It is a key value store right? And it uses raft consensus algorithm. It uses a raft consensus algorithm for strong consistency and availability. For strong consistency and availability, right? And these things. So, example, when you use this kubectl objects, get like you say that kubectl get po this command when you run this, right? What you are doing is that you are getting the output from where? You are getting the output from the HCD only, because this is the place where it stores all configurations, states, and metadata of Kubernetes object. What does it do? It stores all the configurations, states, and metadata. When I talk about metadata, it can be pods metadata, it can be secrets, it can be daemon sets, it can be deployments, it can be config maps, it can be stateful sets, and etc. 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 Whatever these all are nothing, these all are the objects of this. Okay. It will keep an eye, HCD will keep an eye to watch the events, to watch the things using a watch API. Okay. It will use a watch API, right? It will do the things to track the changes in the state of these objects. Okay. To track the changes in the state of objects. Okay. It stores all the objects, all the details under/registry directory key in the key value format. Example, if you have a pod which is having a name as nginx, so it will store that name as /registry/pod/ whatever the namespace or things are there default as a nginx. So HCD is doing nothing. It basically set and watch. Okay, it sets some watches, subscribe to that watch API on the key spaces to monitor further changes. Right? Whatever the changes are there happening by the Kube API server, it will be notified, and it uses it exposes. This is very important. It exposes key value API or using gRPC protocol. gRPC gateway or gRPC protocol is nothing. It is a RESTful proxy. It is a RESTful proxy which translate all your HTTP API calls. gRPC is a RESTful proxy. We write like this. RESTful proxy that translates all your HTTP API calls into gRPC messages. So in a nutshell, HCD is what? It is the brain of a Kubernetes cluster which stores all the metadata information for the Kubernetes object. It stores all the state of the cluster. It stores all the configurations of the cluster under the directory name as /registry, works with the algorithm known as a raft consensus algorithm, and all the communication which happen via the gRPC mechanism. Does this make sense or not?
Yes, Sachin.
Any doubt, any question, Sagar, Moin?
No, it's clear.
These components are very, very important. Sarath, clear? Salim?
Yes.
Good. Now, one another important part is that you will see stateful set in future, but HCD is the only stateful set component in control plane. I'm not saying an entire Kubernetes again. I'm saying it is only stateful set component in control plane. Can anyone help me understand what do you mean by stateful set versus stateless?
Stateful preserves the information between sessions. Stateless actually doesn't preserve any information or data.
Exactly. Stateful set means the same, that we can store the information. We can have those information with us but the other doesn't have. So as this is a database, this is a stateful set component in the control plane. The next component, the next thing which is responsible here is the kube scheduler. Kube scheduler is very again important component because this is the component which is responsible for scheduling your Kubernetes pods on the worker nodes. Means on which pod, on which node, on which a component, the job, right? The action whichever has gone or whichever has been triggered has to run. That is, sorry, that is basically taken care by this Kubernetes node. That is basically taken care by this Kubernetes node. This is Kubernetes worker node. Kube scheduler basically takes care of all of these components, all of these things. Whenever you deploy any pod, right? Whenever you deploy any pod, whenever you say that, okay, I'm deploying a pod is what? It's a smallest unit, okay? It's a smallest unit of a Kubernetes. Because a pod can be short lived, a pod can run continuously, but it has a life until your application is running. We'll talk about pod in detail. However, consider that whenever you deploy a pod, whenever you say that, okay, you are running a pod, you give some details like you say that, okay, there is a CPU, there is a memory, there is a taints, tolerations, priority, volume, and a lot of other things has to be there. The scheduler, Kube scheduler task is very, very simple. It says it is responsible to identify that the request which has to be created, what is the best node, what is the best node, what is the best EC2 machine, or whatever the component you are running for that node is responsible to satisfy that requirement. Example, you want that, okay, CPU, I want 2 cores, I want memory as 4 gig. Now you have two nodes, okay? You have two nodes running, let's say. Now when you have two nodes running, there is one node which is having memory left as 1 gig only. And there is another node, second node, which is having memory left as 6 gig. So Kube scheduler will see that, okay, there is a second node on which we can fit this because this requires 4 gig. If this requires, let's say, memory as a 0.5 gig, right? So it can go with the one node also, right? Or again, it will do a smart decision and say that no, one node is this can be the memory can exhaust, so I can keep on this only as it has enough memory. So this is a task of Kube scheduler, which basically does the same thing, right? It does what? That as soon as there is a pod create request. So how does the flow works right here? The flow works in this way. The pod create request came in. Example. Okay. The pod create request came in. As soon as your pod create request will come in, it will do what? The Kube API server, right? It will to whom the pod request will come in. It will come to Kube API server, correct? The Kube API server will do what? It will basically update the pod state. It will update the pod state where to HCD database. To HCD DB, it will update the pod state. As soon as it is done, right, update the pod state, API server will acknowledge the request. It will say, okay, I'm going to create this. I have acknowledged it. Kube scheduler will keep an eye, right? It will again watching it, right? Using Kube scheduler, using that watch functionality, using that watch API. This is also keeping an eye, right? It detects that there is an unassigned pod. It detects an unassigned pod and it will create pod to node binding, right? It will create a pod to node binding. That means it has to now do the next job. As soon as this is done, it will send out all of these messages to where? To API server. API server will again save the pod state because there is changes happen. So API server will save pod state to HCD if there is any update, right? And the cube, there in the worker node there is a kubelet, right? Worker node there is a kubelet where it will watch. Worker node there is a kubelet which will watch for the bound pods, and kubelet will get the pod specifications, right? Kubelet will get the pod specifications and bind the pod to node. As soon as all of these things are done, it will start the containers in the pod. They will start containers in the pod, okay, using the container runtime interface. And once all of these things are done, again, the state is going to be, the final state is going to be saved in the etcd. This is how this entire thing works. In a simple nutshell, the point is very simple, that as soon as the pod create request comes in, this all happens in such a millisecond of a time, where you update the pod state to the etcd database. The API server will acknowledge the things, right? It will acknowledge the request. The kube scheduler will kube scheduler will use the watch functionality. It will detect the things. It will go ahead and it will create pod node binding, and it will finally run the container and do the things. So there are a lot of parameters. There are a lot of things which are responsible for this entire filtering and the selection mechanism. Once the node is selected, once the things are done, the scheduler will bind it to the event, to the API server, and accordingly they will start taking place further. Like the things will be start going over. Okay, any question here? No question. Not under. How many of you are not understanding anything? Lot of new components, new things.
Yeah, a lot of new things.
See, yeah, this is architecture. Okay, I'm just trying to right now give you the brief on the architecture. Architecture is Kubernetes architecture itself is very complex to understand. You will able to relate to a lot of different things by tomorrow end. To be very honest, okay, you will be able to relate to a lot of things by tomorrow end, because when you start seeing the things in practical. But there are, you say, right, that there are nuances attached to all of the things. I can't show you in practical right now, because if I show you in practical, you will don't know what how the things work. But when I tell you a brief of the things right now, it will actually help you to understand tomorrow, when we will run the pod, when you will run the things, when you will set up the stuff. Okay. So currently it all will be reiteratable once we have done the entire architecture, and once we have started with some demo or running pod and stuff, then again when you will see the things right back, you will see that okay, this is how it is working. So we talked about kube scheduler, we talked about etcd, we talked about kube API server. There are two more components in the control plane which are left over. Kube controller manager. Kube controller manager. With that, first of all, the question comes in, what are these controllers? What are these controllers? Controllers are nothing, they are some, you can say, the programs, which which keep on running continuously. And their main task is to watch for the actual state and the desired state of the objects. Okay, watch for actual state and desired state. The task is simple. This is the actual state, this was the desired state. So I have to ensure that the object is in always the desired state. Object is always going to be in the desired state. Example, you want to create a deployment, okay, for the Kubernetes, where you have said that you wanted to have 3 replicas. You wanted to have 3 replicas and 1 config map. Now this controller will come into the action, right? There will be a deployment controller. Every object, every component has a controller. So there will be a deployment controller which will come into the action and which will say, hey, I need this 3 replicas, I need 1 config map. But as I don't have But as I don't have the until the three replicas of the pod, until the country this config map, all of these things are not created, the desired state will not be matched, right? The desired state will not be matched. So in that case, the things are pretty simple. It will keep on watching until the desired state is matched. As soon as the desired state has been updated, as soon as the desired state has been achieved, the controller will say, okay, I am good. The task is very simple. It will do watch, it will analyze for the pattern, and it will act. Okay, the controller does the simple task, the simple thing, that they will watch for the things, they will analyze the things, they will act on the things. There can be any controller into the pods. What are the number of controllers or the built-in Kubernetes controller we have are deployment controller. We have replica set controller. We are having daemon set controller. We are going to have a job controller. We can have a cron job. No, not cron job. We'll have an endpoint controller. You have a node controller. You can have the namespace controller. So controller can be anything. For each Kubernetes objects, the controllers can be there. For each Kubernetes object, there can be the controllers, right? So controller is what? It is simple, which basically manage all the cluster's desired state. Okay, you can also have your own custom controller also. Now the cloud controller manager, which was written, the CCM, that is nothing. When you deploy the thing into the Kubernetes, when deploy the Kubernetes into the cloud, right, into AWS, Azure, GCP, then there is a cloud API also coming in, right? There is going to be the interaction happening between the cloud API and between your Kubernetes cluster. So there this cloud controller will come into the picture, which will ensure that whatever the resources, whatever the things you are provisioning, whatever the stuff you need, all those things are available. All those things are available to its desired state. That is all the responsible task of the controller manager. Okay, the controller manager is doing nothing. It is basically going to ensure that everything is up and running. It is everything is at its desired state. Okay, these are doing nothing. These will just do simple stuff. They will watch, update, watch, update. That is what they are going to do. Watch for the change. Okay, change is there, update it. Change is not there, keep on sitting. Getting it? They are doing a basic security guard job. Now we will talk about worker nodes. We'll talk about worker nodes. We have already looked over the Kubernetes controller node. Control plane. We have talked about that. And we have talked about the components between that. That is the controller. We have talked about the etcd. We have talked about the Kube API server. We have talked about the other components which are important here, scheduler and things. We'll talk about the worker node. And in the worker node, we saw the very important first component was kubelet. The very important component was kubelet. Kubelet is nothing. It is, it is an agent. You can say it is an agent component which runs on every single cluster or every node in the cluster. Kubelet will be running on the every node in the cluster, because this is the one which is helpful to register your worker nodes with the API server. It talks to the API server, right? It is the one which talks to the API server. Okay, it is the one which is responsible for your creation of the pods, for managing of the pods, right? So we also call it as a node agent. We also call it as a node agent. Okay, because it runs on each worker node. right? It ensures that the container defined in the pod specifications are running and healthy on their respective node. Okay. It is responsible for doing the pod management, means creation, updation, delete, modify, whatever it is, all these things will be there. It is going to talk to your container runtime in the, that is the CRI, okay, which is what container runtime is, Docker, right? In Kubernetes, when we are using Docker, if you are using any other thing, it will be other thing, or container D, right? So it is responsible to ensure your container lifecycle is managed. Okay, it will talk to the container runtime and start, stop, restart containers whenever needed. It will monitor the health of the containers. Okay, it will do the health monitoring of the pod by liveness and readiness probes. Okay, these are very important components again. It will manage the resources. Manage the resources means your CPU and memory. All those things will be monitored and managed. Okay. Volume management. The persistent storage and things which we put, all those things will be managed. It does more other tasks. So overall, in a nutshell, right, Kubelet is nothing. It helps us to bridge the gap between the control plane and the worker node. How? By ensuring that it can manage each and everything. It talks to the containers. It talks to the sorry. It helps us to talk to the node, and it is responsible to manage the each and every component.
Does it run at the node level or does it run in each pod, Sachin?
Node level.
Okay.
It runs on every node here. It runs as a daemon set, not as a container.
Okay.
Daemon set means the same, that things which are running as this. We'll talk about that again. Kubelet is a container controller also, because it will watch for the changes, the pod changes, and accordingly it will use the container runtime to pull the images and other things. Okay. So Kubelet is very important part. Okay, Kubelet is very important part. It is a very helpful part to store a lot of different like things and information, right? It uses the container runtime. Again, gRPC is the interface with which it talks. Okay, and it also uses the CNI plugin. It uses the CNI plugin. It uses the CNI plugin in cluster, that is a container network interface, to allocate the pod IP address. Okay, and to have a other kind of information, whatever is needed. So these are all the things it does too. So yes, kubelet is very important component which is responsible for to ensure that it has the all the Kubernetes manifest and things are there. It manages the container network interface, the pod specification and things. It looks for another stuff. Now another important part which you have is Kube-proxy. What is this Kube-proxy? So when we talk about the Kube-proxy, right? When we talk about the Kube-proxy, it is nothing, it is some service, which is responsible for the network management, you can say, right? Kube-proxy is a service which is responsible. It is a daemon set, right? It runs on every node as a daemon set. Okay. It runs on every node as a daemon set, and it is a service which is responsible to ensure all the network and all the things are talking. Example, Kube-proxy will do what? It will talk to what? Again to the API server, and it will get the details of the service, right? It will get the respective pod IPs, respective ports and other things, and it will keep on monitoring for all of those things. Okay. So Kube-proxy is another very important component, right? Or you can say it's a network proxy, okay, which runs on each Kubernetes cluster, and it is responsible to implement or to give the virtual IP for Kubernetes service. Okay, it will give the Kubernetes services as virtual IP, right? It will give you the port, it will give you the IP, it will do the service discovery part and these things. Whenever your multiple pods and other things, right, those will be running, right? Kube-proxy will help you to distribute the traffic also, distribute incoming traffic, okay, among multiple pods. So it acts as a load balancer. It helps you to manage your endpoints, okay, help you to manage your endpoints. And definitely it also helps you to traffic redirection using a different network rules, okay, using a different network rules and things. It helps us to do the traffic redirection also. So it route the traffic and the things by using a IP tables, which is the default mechanism here, right, where the traffic is handled by the IP table rules. Means for each service, there is a IP table rule will be created, IP table rules, and these rule will have what? They will have a traffic. IP table rule means whatever the cluster IP and things will be there, to which the traffic is coming in. So it will take that traffic and forward it to the pods. Okay. The Kube-proxy will do that way. There is also, the IPVs, means whenever the clusters, which has a high number of services, very large services, let's say that services more than 1000 and all, right? There is something known as IPVS, which, or we call it as IPVs, which is helpful for the performance improvement. Okay. That is helpful for the performance improvements and these things. Okay. We call it as IP virtual server. What we call it as IP virtual servers. Okay. So that is also there. And again, like for Windows and all, it uses a kernel space, right? There is a one thing known as a user space, which is legacy method not being used and put up. In a simple terms, understand that it is responsible for network management of the containers or of the pod, Kubernetes pods. Container runtime. This is nothing but consider it as a JRE. JRE is what? Java runtime, right? Which means what? That it was a software, right? JRE was always required. Today also, if you have a Java application, if you don't have JRE installed, you cannot run the Java program. Likewise, if you don't have a CRI, if you don't have a container runtime, right, you cannot run the containers into the Kubernetes. So container runtime is nothing. It runs on all the nodes. It runs on all the nodes in K8's cluster, right? And this is the one which is responsible to pull the images, right? Run containers, okay? Allocate resources, okay? And manage entire container lifecycle. So CRI is nothing. It is set of APIs. It is set of container runtime interface, right? Is a set of API. It is set of this thing which is responsible to interact with the different container runtimes. Okay. Responsible to interact with different container runtimes. CRI is set of APIs that allows Kubernetes to interact with different container runtime. Container runtime and CRI could be anything, it can be a Docker, it could be your container D or C advisor, anything, whatever you are using. There is also something known as OCI, that is Open Container Initiative. Okay. So again, this is again the new set of standards, for container formats and runtime. We call it as Open Container Initiative. So Kubernetes supports, like this multiple container runtimes. Again, you can have multiple container runtime. As I said, Docker, C advisor, you can have the container D, you can have the CRIO, a lot of different things. Commonly being used is this thing, right? So as soon as the kubelet which is there, that will talk to the container runtime, right? That will talk to the container runtime and it will say that, hey, we have this pod specification. We have to pull this pod image, right? We have to manage this container lifecycle. So please go ahead and do your task. So that is where, as soon as a new request will come in, right, Kubelet will talk to the container runtime, right? And it will ask it to launch the required containers, pull the required images, right, and do the things. Now, apart from this, we have some Kubernetes add-on components. Okay, we have Kubernetes add-on components, which we install based on the needs and the things. The add-on components are nothing. One is the CNI plugin, which we talked about. That is the container network interface. Another one is core DNS service. This is helpful for the DNS resolutions and DNS servers, right? This is going to be acting as a DNS server for your Kubernetes cluster, DNS server for your K8s cluster. Okay, you enable DNS-based server discovery. Metrics server. Metrics server is nothing. Again, it is responsible for your metrics. It will help you to collect the resource usage of nodes, of pods, and other things. So for monitoring purpose, this is important. And the last one is known as a web UI, or you call it as a Kubernetes dashboard. Kubernetes by default provides its own dashboard also, which can be open and which can be used using this way. Okay. So a lot of companies and things, they use the CNI plugin, right? And the Kube controller manager and things is going to talk to the CNI plugin, and it gets the IP and other things. Okay, so that is how that is responsible. Okay, now there are a lot of different CNI plugin, right? For VPC and things, we use the AWS. If we are using, we are going to use the AWS VPC. Okay, there is Calico is one of them, which is very good, famous one. Flannel is there, ViewNet. So you can have other kind of plugins also. Azure, in case of Azure, CNI is there, and lot of these things. Okay. Now in Kubernetes, we have a lot of things. We call it as a Kubernetes objects. Okay, Kubernetes native objects. So whatever you components, whatever things you are there, right? All of these until now were part of the architecture, but now what we are going to, the way these components work, right, or the way this all these are being managed, we call everything whatever is there as object, like pods, namespaces, replica set, deployment, daemon set, stateful set. Okay, jobs and cron jobs in Kubernetes, right? Config map. Okay, all these secrets, all these are what? These all are your Kubernetes objects. Okay, with respect to networking and things, you have the services, right? You have the services. Okay, you have the network policies. Okay, you have the ingress services and these things. So this is this is all about the Kubernetes architecture. This is all about the Kubernetes things, that how does the things work, what are the kube add-on components, what are the Kubernetes native objects, right? And about the architecture, why it is important, why the Kubernetes architecture is very, very important. A lot of times, when the interview happens, right, they will ask you the Kubernetes architecture, and then entire interview will go in that only, because they will ask you the questions. What is the use of Kube-proxy? What will happen if my Kube-proxy will go down? What will happen if my Kube API server itself will go down? What is going to happen if my HCD goes down, right? So what if the Kube scheduler is not working, right? What happen if the CNI is failing? So there are a lot of questions which we will be seeing in the future sessions come, or it goes around and around for this Kubernetes only. Okay, that all goes around with the Kubernetes only. So that is why it is very, very important to have an understanding of this entire Kubernetes architecture. So in the next session, we will see the installation of the Kubernetes. We will see the different mechanisms, like how to run it as a single node that is on a mini cube, how we can set it using the on a different standalone EC2 instance. And for our purpose, we will also try to spin it up on the EKS, so that we will see that how in the AWS EKS service we can use it. So this is all about the foundation of Kubernetes. This is all about the basic of Kubernetes.